James Webb Space Telescope, people have been working on this for over 25 years, was because, as the saying goes, they needed a lot of miracles.
For decades, Bill Nye, the beloved science guy, has piqued our interest in the cosmos, making the vast world feel a little more accessible.
We're taking pictures of these objects with astonishing precision. It's like, whoa.
Now that the James Webb Space Telescope is capturing amazing photographs from over 13 billion years ago, Bill's joy is apparent.
Come with me today while we explore the vast, wonderful world of outer space.
These pictures have the potential to revolutionize our understanding of the universe, as well as our perceptions of life. The James Webb Space Telescope, already regarded as a viable successor to Hubble, promises groundbreaking discoveries.
James Webb will go where no other telescope has gone before.
So I have to catch more photons. I need a bigger mirror. I need something 7 times bigger than Hubble.
So, what fresh discoveries are being made, and how does Bill Nye perceive these cosmic wonders? Let's look at the latest celestial disclosures. The creation of the James Webb Space Telescope. The James Webb Space Telescope, also known as Webb, is the result of years of hard effort by NASA scientists and engineers. The telescope was launched on Christmas 2021, and its deployment over the next few months was a painstaking procedure that went ahead without a hitch. The telescope was operational by late June 2022, and scientists made incredible findings within days. Thousands of new galaxies, older and further away, began to appear. Some of these galaxies were found to be more than 150 million years older than the oldest galaxies observed by the Hubble Space Telescope. Webb's unparalleled ability to collect light from astronomical objects like exoplanets and developing stars enables it to reveal their compositions and motions across space. Bill Nye underlines that Webb's data has already begun to reveal the atmospheric makeup of planets hundreds of light years away, implying that they may be capable of supporting life as we know it. The Hubble Space Telescope recorded one of the most iconic pictures of the Eagle Nebula, known as the Pillars of Creation. These towering clouds of gas and dust, which are the centers of intense star formation, have long captivated astronomers and the general public alike. While Hubble's visible light photographs revealed the beautiful clouds around the pillars, the actual process of star formation within them was veiled. The James Webb Space Telescope, with its infrared imaging capabilities, has pierced the clouds to expose what lies beneath. Webb's photos show protostar clusters, which are enormous clouds of dust and gas many times larger than our solar system, forming tiny red dots against the pillar's murky backdrop. According to Bill Nye, protostars are stars in their early phases of formation. At this time, these young stars are not yet devouring hydrogen. However, as more material is sucked into their centers, they become denser and finally reach a critical point where hydrogen burning occurs, causing the star's temperature to rise to approximately 2 million degrees Celsius. Different colors were utilized in the illustration to depict the infrared wavelengths, which are mostly invisible. To the human eye, the blue parts of the image are actually red. The wavelengths of the hues in the image rise with radiation, with the red sections, such as the protostars, emitting radiation at a wavelength that is approximately 6 times that of the human eye. According to Bill Nye, this image not only demonstrates Webb's infrared capabilities, but also sheds light on the birth of stars like our own sun. The search for exoplanets. The search for exoplanets, or worlds outside our solar system, has been one of modern astronomy's most exciting endeavors. Since the first exoplanets were discovered in the 1990s, the field has proliferated, with over 3,000 confirmed exoplanets cataloged to date. However, the issue is not simply discovering these faraway worlds, but also seeing them. Direct imaging of exoplanets has proven to be one of astronomy's most difficult challenges, with only approximately a dozen exoplanets successfully observed. This is largely due to the enormous distances involved and the overwhelming brilliance of their parent stars, which frequently outshine the planets by a factor of billions. Most exoplanets are detected indirectly, such as the transit method, which detects a slight dimming of a star's light as a planet passes in front of it. However, the landscape of exoplanet research is fast changing due to the groundbreaking capabilities of the James Webb Space Telescope. Webb, which was launched with the promise of altering our understanding of the cosmos, has exceeded expectations. James Webb Space Telescope made history last September by capturing its first direct image of an exoplanet, a big step forward in our abilities to study these faraway worlds. The exoplanet is HIP 65426b, a massive gas giant discovered in 2017. Unlike many exoplanets identified indirectly, Webb observed HIP 65426b directly with its advanced arsenal of telescopes. To accomplish this, scientists used Webb's coronagraphs, which are instruments designed to filter out the bright light from the exoplanet's host star, allowing the dim light from the planet itself to be identified. The telescope's exceptional sensitivity, paired with powerful infrared cameras and a variety of filters, enabled it to capture an image of this distant world with incredible clarity. HIP 65426b is an exceptional planet in many ways. It is almost 12 times the size of Jupiter, making it a true behemoth among gas giants. Furthermore, it orbits its host star at an incredible distance, 100 times that of Earth and the Sun. HIP 65426b's enormous separation from its star made it a good target for direct imaging, as the planet is far enough away from its star to be identifiable even with current equipment. The successful imaging of HIP 65426b is more than a technological accomplishment. It heralds a new age of exoplanet exploration. By taking a direct view of this faraway world, Webb displayed its ability to investigate exoplanet atmospheres, compositions, and maybe even weather patterns. Data collected from HIP 65426b has already begun to disclose previously unknown characteristics, providing insights into the genesis and development of gas giants in our galaxy and beyond. However, arguably, the most intriguing aspect of this discovery is what it means for the future. HIP 65426b is only the beginning. The James Webb Space Telescope is poised to discover a treasure trove of exoplanets, many of which may lie in the habitable zones of their stars, the regions where conditions may be ideal for life to exist. The Phantom Galaxy. The Phantom Galaxy, also known as M74, is one of the most captivating celestial phenomena observed by the James Webb Space Telescope. Despite its elusiveness in the night sky, the galaxy's brilliance is seen in Webb's infrared pictures, affording an unprecedented look at this cosmic masterpiece. While Hubble's optical photographs have long shown M74's exquisite spiral structure and the elegant dispersion of stars along its arms, Webb's newest infrared studies offer a completely new dimension to this galaxy. The most recent photographs from Webb's upgraded infrared cameras reveal complicated formations that appear like luminous fibers spreading from a brilliant central core. These threads, made of heat-emitting dust and gas, are portrayed in a striking electric blue, providing a stark contrast to Hubble's more typical optical views. This advance in infrared photography has allowed astronomers to see deeper into the galaxy's star-forming regions, which are spread throughout its spiral arms. Webb's capacity to capture the galaxy at many wavelengths has improved our understanding of these regions, revealing comprehensive information on the processes that regulate star formation. Scientists can obtain a better understanding of the properties of interstellar dust and gas by inspecting these star-forming regions with Webb's enhanced clarity. Researchers from the European Space Agency used Hubble and Webb data to generate a magnificent composite image of M74 in order to provide a more comprehensive view. This composite, a fundamental component of the high angular resolution in nearby galaxies international project, combines Hubble's optical clarity with Webb's infrared precision. The project combines observations from both space and ground-based telescopes with the goal of capturing infrared images of 19 neighboring star-forming galaxies. The combination of Webb's high-resolution infrared data and Hubble's optical images yielded a magnificent composite that emphasized the galaxy's rich architecture and dynamic dynamics. Webb's observations represent a big step forward in our abilities to study and understand distant galaxies. Webb's capacity to detect longer wavelengths of light gives astronomers a better tool for pinpointing star-forming regions than ever before. This, in turn, enables more precise determinations of the masses and ages of star clusters in these galaxies. Furthermore, the increased visibility of small dust particles in interstellar space contributes to a better knowledge of the galaxy's materials and the processes that occur within it. The mysteries of Wolf-Rayet stars. In July 2022, the James Webb Space Telescope, with its unequaled imaging capabilities, focused on a faraway celestial object known as WR-140, a Wolf-Rayet star. The final image was nothing short of stunning, with Webb's trademark diffraction pattern, a starburst effect created by the telescope's hexagonal mirrors that appear as sharp, spike-like lines emanating from the star. What particularly intrigued the scientific community was the intricate ripple-like formations surrounding WR-140, concentric rings that appeared to defy traditional assumptions with their slightly angular, nearly boxy appearance. Unlike the diffraction pattern, these ripples were not imaging artifacts, but rather true elements of the star system, indicating a more intricate tale. WR-140 belongs to the Wolf-Rayet star class, which is both unusual and interesting. These are enormous, evolved stars that have already shed a large percentage of their outer hydrogen layers, releasing them into space. This expulsion produces a turbulent environment rich in heavy components like carbon and nitrogen, which are blasted into space at incredible speeds. Wolf-Rayet stars are frequently found in binary systems, where their gravitational pull is strongly connected to that of a partner star. In the instance of WR-140, it is this relationship that causes the unusual patterns shown in Webb's photograph. The concentric rings around WR-140 are the consequence of a complex interaction between the Wolf-Rayet star and its smaller, less massive companion star. As these two heavenly bodies dance around one another in their orbital embrace, they cause periodic waves in the gas and dust surrounding them. Each time the stars get near together, the material between them compresses, forming a new ring. Over time, these interactions form layer upon layer of concentric shells that stretch into space. The form of these rings is very intriguing. Rather than being perfectly circular, they have a slightly boxy form, implying that the relationship between the two stars is more complicated than a simple circular orbit would suggest. This could be owing to a number of factors, including the elliptical structure of the star's orbits or the influence of strong stellar winds emitted by the Wolf-Rayet star. Webb's powerful equipment has captured these features with remarkable precision, allowing astronomers to analyze the intricate patterns in the surrounding gas and dust in previously unimaginable ways. Reaching the farthest galaxies. The James Webb Space Telescope, a modern astrophysics marvel, was designed to peer across the universe's early stages. Its objective was to travel back in time, gathering faint whispers of light from the first galaxies formed in the aftermath of the Big Bang. By mid-December of the previous year, this ambitious quest had achieved incredible results. Researchers revealed a major achievement. Webb discovered 4 galaxies that are now acknowledged as the earliest ever observed. These cosmic remnants, glimpsed 13.4 billion years ago, existed when the universe was only 350 million years old, or 2% of its present age. This historic discovery occurred as part of the telescope Advanced Deep Extragalactic Survey, a massive observational mission that used Webb's near-infrared spectrograph. This equipment was critical in understanding the universe's remote history. Scientists used redshifts, the stretching of light waves as the cosmos expands, to establish the ages and distances of the galaxies. The galaxy's redshifts reached an incredible 13.2, the highest redshift ever recorded. This discovery is really significant. Prior to Webb's findings, theoretical models could only conjecture the presence of such old galaxies. The discovery of these galaxies' extraordinary antiquity challenges earlier beliefs and adds to our understanding of the early cosmos. The telescope's capacity to discover and verify such distant galaxies opens up new possibilities in cosmic research. For the first time, we are able to observe these ancient celestial objects while also verifying their existence by spectroscopic research, ensuring that they genuinely exist in the far reaches of the universe. The consequences of this revelation go far beyond scholarly interest. By peeking into the universe's early beginnings, the telescope sheds light on the environment and processes that shaped the first galaxies. This knowledge is critical for understanding how the universe formed and evolved. Scientists will learn about the origin and growth of galaxies, star formation, and the overall development of the cosmos during its earliest years when they analyze data from these ancient galaxies. WASP 39b. Webb has not only studied faraway galaxies but also worlds considerably closer to home, albeit still well beyond our solar system. Webb has completed one of the most exhaustive exoplanet surveys to date, focusing on WASP 39b, a planet circling a star in the constellation Virgo. WASP 39b is a gas giant the size of Saturn that is 700 light-years away from Earth. However, unlike Saturn, this planet orbits its host star much closer than Mercury does to our Sun, forcing its atmosphere to reach boiling temperatures. Despite the severe conditions on this planet, Webb's instruments have yielded a plethora of data about its atmosphere. Scientists used the telescope's main camera and 2 spectrographs to detect carbon dioxide in the atmosphere of WASP 39b, the first time this gas has been found in an exoplanet's atmosphere. Additionally, the planet's thick atmosphere was discovered to include clouds of sulfur and silicates, including sulfur dioxide. These discoveries reveal new light on the planet's genesis and history, explaining how such remote and hostile worlds came to be. The planet is thought to have formed at a significantly larger distance from its star than its current location. This origin is attributed to the collision of smaller planetesimals, as evidenced by the planet's atmospheric composition, notably the increased presence of oxygen relative to carbon. This elemental imbalance shows that the planet has changed significantly since its formation, possibly moving closer to its star over time. Such planetary migrations are widespread in the cosmos and can have a significant impact on a planet's ecology and ability to support life. Interesting features of Saturn's moon Titan. Saturn's moon Titan is a distinct and intriguing celestial body. Titan, unlike any other moon in our solar system, has a rich atmosphere and contains liquid methane and ethane, which form its rivers, lakes, and seas. Titan's surface is coated with water ice, which acts as the moon's bedrock, in stark contrast to the liquid hydrocarbons that flow across its terrain. Titan's atmosphere is so thick that it even contains methane clouds, a feature unique to this moon. Scientists discovered these methane clouds in November of the previous year when the James Webb Space Telescope collected atmospheric data from Titan. The discovery sparked excitement in the scientific community when NASA released data confirming the presence of at least 2 clouds, one of which was located above Kraken Mare, Titan's largest sea. This observation was so intriguing that the study team contacted Hawaii's Keck Observatory only 2 days later to perform additional Titan studies. The Keck data confirmed the presence of the cloud over Kraken Mare, but its shape had altered, implying that either the cloud had evolved or another cloud had moved into the same location. Scientists are keenly interested in Titan's dynamic atmosphere, as they intend to utilize it to map the planet's haze and detect new gases. Southern Ring Nebula. Many astronomers have long considered the Southern Ring Nebula to be an uninteresting cosmic formation. It was assumed to be simply a white dwarf, a fading star that had shed its outer layers but continued to shine brilliantly due to the energy emitted by the white dwarf. This nebula was discovered to be part of a binary star system, with the white dwarf partially covering its dying partner star. However, the James Webb Space Telescope's breathtaking image of the nebula, released alongside its initial set of photographs and data, called into question these conventional notions. Two of Webb's instruments, the near-infrared camera and the mid-infrared instrument, took images of the nebula that showed unexpected details. Contrary to predictions, the white dwarf was visible in mid-infrared wavelengths, appearing as a bright red object surrounded by a haze of frigid gas. This surprising finding sparked questions regarding the gas's origin. Bill Nye, a renowned science communicator, speculated that the gas could have come from a third, hidden star within the nebula, giving the only possible explanation for its presence. Webb's primary camera also captured interesting shell-like features around the nebula's edge, comparable to those found around WR 140, another celestial object. The team proposed that a third star, placed between the two already found, could be responsible for the ripple-like shells. Despite original assumptions that the gas and dust in the Southern Ring Nebula were fully created by the partner stars, fresh evidence indicates a more sophisticated and directed ejection of material. Webb's unexpected discovery. The James Webb Space Telescope, a modern astrophysics marvel, was not developed with exoplanet detection in mind. Its major purpose was to explore the universe's deepest depths, revealing the earliest galaxies and cosmic architecture. However, in an unexpected twist, the telescope discovered an interesting object that defies traditional classification, a brown dwarf dubbed VHS 56b. Brown dwarfs are fascinating celestial bodies that fall somewhere between a planet and a star. They are too huge to be categorized as planets, yet lack the mass required for hydrogen fusion, which is the distinguishing feature of stars. VHS 56b is a prominent example of this transitional nature, having a combination of star and planetary characteristics. Despite its larger size than a typical planet, it fails to achieve star status due to a lack of mass. What distinguishes VHS 56b is its composition. The telescope's superior sensors uncovered a unique atmospheric feature, sand and silica clouds. This is remarkable for a brown dwarf, as such a composition is rarely seen. Brown dwarfs typically have more conventional cloud forms. Therefore, the inclusion of sand and silica is an interesting outlier. Furthermore, VHS is younger and smaller than its brown dwarf relatives, adding to the mystery. This means that it has not yet had the opportunity to grow into a more typical brown dwarf, yet its size positions it at the lower end of the brown dwarf range. The telescope's observations also revealed specific atmospheric constituents, including water, methane, carbon dioxide, and potassium. The ratio of these elements points to a highly turbulent atmosphere. This turbulence causes vertical mixing, which transports carbon dioxide from the depths of the atmosphere to higher altitudes, where it reacts with methane. Such dynamic mixing results in a chaotic, ever-changing environment. A planetary enigma. Among the many celestial discoveries discovered by the James Webb Space Telescope, the exoplanet WASP 96b has emerged as a particularly intriguing subject, providing insights that challenge our knowledge of distant planets. Webb revealed the first-ever detailed spectrum of an exoplanet's atmosphere as part of NASA's unprecedented inaugural data release, a huge step forward in the study of planetary atmospheres beyond our solar system. This spectrum, which is sometimes compared to a barcode, represents the specific wavelengths of light absorbed by the planet's atmosphere, indicating its chemical makeup and other important properties. WASP 96, AB, a gas giant over 1,000 light-years away from Earth, was once assumed to have a clear sky. This notion was based on earlier observations that revealed a high sodium signal, indicating that the planet's atmosphere was essentially cloud-free. The sodium signal, a common feature in exoplanetary atmospheres, revealed that the starlight traveling through the planet's atmosphere was unimpeded, allowing for a precise investigation of its composition. However, the spectrum collected by the Webb telescope revealed a different picture. Rather than the expected pristine sky, Webb's data revealed the presence of water vapor, clouds, and haze in the planet's atmosphere. This was a surprise and puzzling result because it directly contradicted earlier assumptions about WASP 96b's atmospheric parameters. The discovery of water vapor clouds indicates that the planet's atmosphere is more complicated and dynamic than previously imagined, with layers of varied opacity that may influence how light is absorbed and emitted. The consequences of this discovery are profound. For starters, it has spurred experts to re-examine both Webb telescope data and previous observations to better explain the apparent discrepancies. This re-evaluation process is critical because it may lead to new models of atmospheric behavior for hot Jupiters like WASP 96b, where severe temperatures and radiation from the host star might result in unique and complicated atmospheric phenomena. WASP 96b is a fascinating world. It is classed as a hot Jupiter, a type of exoplanet that is roughly the size of Jupiter but orbits much closer to its star, resulting in extremely high surface temperatures. WASP 96b is almost the same size as Jupiter but has half the mass, making it far less dense. It orbits its parent star every 3.4 days, putting it in an environment with temperatures exceeding 1,000 degrees Celsius. Despite the presence of water vapor in its atmosphere, the planet's searing circumstances make it improbable to support life as we know it. The detection of water vapor on WASP 96b is very significant, because water is an important signal in the hunt for potentially livable environments. However, the harsh conditions on WASP 96b indicate that this water is most likely in the form of high-altitude clouds or steam rather than liquid water, which is required for survival. Search for extraterrestrial life. The discovery of water vapor on WASP 96b has sparked renewed interest in the quest for life outside our solar system. Bill Nye and other scientists have argued that finding a planet with a methane-rich atmosphere could be a significant indicator of life. On Earth, biological creatures, mainly bacteria, are the primary producers of methane. Finding methane on another planet may indicate the presence of life forms that produce this gas. The eventual finding of extraterrestrial life would have far-reaching consequences for humanity's perception of its role in the cosmos. It would call into question our long-held assumptions about our uniqueness and the nature of life in general. Are we alone in the universe? Or do other civilizations look back at us, asking the same existential questions? One of the most significant advantages of the James Webb Space Telescope is its capacity to see the universe in infrared light. Unlike visible light, which is obstructed by dust and other cosmic debris, infrared light can pass through these barriers, revealing hidden objects and structures. This feature has enabled Webb to take photos that were previously impossible to obtain, providing new insights into the universe. For example, Webb's image of merging galaxies, which had been covered by Hubble's visible light measurements, revealed an area of strong star production. This patch of merging galaxies, known as IC 1623, is creating stars at a rate 20 times faster than our own galaxy. The image also showed a distinctive pointed star diffraction pattern, which was created by the telescope's observation of brilliant stars in the dusty region. Scientists anticipate that this star-forming zone will eventually give rise to a supermassive black hole, which is not currently apparent in the Webb image. Exploring distant galaxies with Webb. In addition to views of close celestial objects, the James Webb Space Telescope has captured spectacular photographs of distant galaxies. One such image, according to Bill Nye, depicts tens of thousands of stars in a galaxy 17 million light-years away. This galaxy, NGC 568, is well beyond the local group of galaxies, which contains the Milky Way and provides a view into a faraway corner of space. The image shows a dense concentration of stars in the upper left, with a strong bar of white light representing the galactic core. This core contains the majority of the galaxy's stars, making it the brightest section of the image. Astronomers are particularly interested in the strong star formation that is taking place in this region, as they want to learn more about the processes that drive the birth of stars. Webb's observations are part of a bigger study to better understand star formation in neighboring galaxies. Scientists expect that by examining these distant galaxies, they will be able to learn about the mechanisms that regulate star formation and how they change across different settings. The James Webb Space Telescope's capacity to observe in the infrared spectrum is transformative for space research. Webb can peek past cosmic dust and expose hidden characteristics in galaxies, nebulae, and other astronomical objects by using infrared wavelengths that are longer than visible light. This feature is essential for examining the centers of galaxies, where star formation is frequently hidden by dust. Webb's images include IC 5332, a spiral galaxy that has also been spotted in the infrared. This image, like others captured by Webb, demonstrates the telescope's ability to expose fine characteristics of galaxies that would otherwise be concealed from view. Astronomers think that by analyzing these photographs, they will be able to increase our understanding of how stars and galaxies form. The future of astronomy with Webb. As the James Webb Space Telescope continues its mission, astronomers and scientists throughout the world are looking forward to the discoveries that lie ahead. With its unique ability to observe the universe in infrared light, Webb is set to transform our understanding of the universe from investigating star formation in faraway galaxies to looking for signs. Thanks for watching. Stay tuned for more interesting content.